Hello and welcome to this video on momentum. Now here the aim is to use the definition momentum equals mass times velocity and to understand that if resultant force on object is zero, its momentum does not change. Let's start first of all by thinking, what is momentum? Okay, now imagine we're at a bowling alley. Here we've got a bowling alley. Now you want to knock over more pins. So what can we do if we want to knock over more pins? Obviously it's get the ball in the right direction. That's not what we're thinking about here. There's two things we can do to actually knock over more pins. One is to actually bowl the ball faster, give it high velocity, or secondly, you can use a heavier ball. Now either of those two will give you more chance of knocking over more pins. Now, so you can use that to think about what is momentum. Now, any object that has both mass and velocity has momentum. So, previous slide we saw there the bowling balls, they have mass, we give it velocity, therefore the bowling balls have what we call momentum. And you could say, what has more momentum? On the left here we've got a bus, and on the right there we've got a little car. I think it's a smart car or similar. Now, if they are travelling at the same speed, which has more momentum? Well, obviously it is the bus, because it has more mass and therefore overall it has more momentum than the smaller car at the same speed. So we could say the momentum is given by the equation mass times velocity. So momentum equals mass times velocity. Units, kilograms, meters per second. Now always remember calculations, check that you've got the mass there in kilograms and also know that there are 1,000 grams in 1 kilogram. So very easy calculations here to have a go at. So first one kilogram football travelling at 10 meters per second, that's simply 1 times 10, momentum of 10 kilogram meters per second. 1,000 gram Ford Capri travelling at 30 meters per second, again multiply those two together, you get the momentum. Now this one here, be careful. A 20-gram pen being thrown across the room at 5 meters a second. Not I hope you'd throw a pen across the room, but there we are. You've got to convert this into kilograms. So that'd be 0.02 kilograms. Okay, make sure you do that times 5. Last one's nice and easy. 70 kilograms times 40 gives you the momentum. Right. Now, forces, because when we're talking about momentum, we have to include forces. Forces can change the velocity of an object. When the velocity of an object increases or decreases, its momentum has changed. Think about it. The equation is momentum mass times velocity, so if we change the velocity, the momentum also has to change if the mass stays constant. Now, change in momentum will happen in the same direction as the force causing the change. Let's have a look at that. Suppose you've got somebody on the swing. Now, if you push someone on the swing, they swing faster. Why? Because their momentum has changed. They may be going happily along their own pace. You add more force to it, their momentum has changed because they're going faster. It's increased in the same direction that we have pushed them. Now, if there is no resultant force, i.e. no overall force, there is no change in momentum. If there is resultant overall force acting on an object, then the change in momentum depends on the size of the force and how long it's applied for. So basically, if you don't push them, there'll be no change in momentum. However, if you push them, there is a resultant force acting on the object, and that resultant force will affect momentum, and that is affected by how large the force, what push you apply, and for how long you apply it for. So those two things there are key to calculating change in momentum. So change in momentum is given by resultant force, how much additional force has been put in, and the time for which it acts. Let's look now at an example of that. Now, here we've got a football. Now, a football is being kicked. Okay, a free kick gives it a velocity of 20 meters per second. So, football has a mass of 1 kilogram. A free kick gives it a velocity of 20 meters per second. So first of all, momentum, very, very easy. It's the mass, which is 1 kilogram, times velocity, which is 20 meters per second. So momentum is 20 kilogram meters per second. Okay, fair enough. Now, what's the change in momentum of the ball? This is when the kick was taken. Well, think about this. Okay, think about moving the ball before the free kick. Hopefully, if it is playing the rules of football, the ball would be stationary. Okay, so momentum before equals naught. So the momentum, if you apply our equation here, the mass is 1, but the velocity is 0. So 1 times 0 is 0. Therefore, momentum before is 0 kilogram meter a second. Okay, when we give it a bit of a kick, the momentum changes to 20 kilogram meter a second. So that is a change there in momentum. Now, suppose the contact time between your foot and the ball was 0.05 seconds. And we can calculate now the force exerted on the ball during the kick. Change in momentum equals resultant force times time. What do we know? Well, we know the change in momentum, that's given here. Okay, we know the time, which is given there. So from those two, we can work out resultant force. So resultant force equals change in momentum, which is 20, divided by the contact time, 0.05, which equals 400 newtons. So the resultant force was 400 newtons in this case. Okay, so let's talk now lastly about the conservation of momentum. When there is an interaction or collision between two objects, the change in momentum of one is equal to change in momentum of the other, but in the opposite direction. Okay, we say momentum is conserved. There's no change in momentum. Let's think about two cars. The two cars are racing. Okay, now they're both going in the same direction. Car A collides with the back of car B, and the cars get stuck together. So what speed they move after the collision? This is a classic momentum type question. So one car is going at 20 meters a second to the right, and has a mass of 800 kilograms. Here's a second car, a slightly sportier version, therefore it's going faster. This is going at a speed of 50 meters a second. It's got a mass of 1,000 kilograms. Now you've got everything you need there to calculate the momentum. Okay, so let's have a look, shall we? They get into a bit of a tangle. The car on the left hits the car in front of it. We've got to work out what the new speed will be. Well, let's think about this. The new combined mass, when they're stuck together, new combined mass is 1,000 plus 800, which equals 1,800 kilograms. Now let's look at the momentum before and momentum after. Now momentum before, what we had this one, so it's 1,000 times 50 plus 800 times 20. And there we have it. So 1,000 times 50 is this car here, plus 800 times 20, that car there. Now that's momentum before. Now momentum afterwards is given by the overall mass, which is 1,800 kilograms, times the velocity we don't know. So all we've got to do is simply put that into our equation. So 1,000 times 50 is 50,000, plus 800 times 20, you can work that out. Divide the sum of those by 1,800, and that will give you the new velocity of the cars stuck together, and that is actually 36.7 meters a second. Okay, and that is as difficult a calculation as you're going to get when looking at conservation of momentum. So hope this little video helps. Thanks for watching, thanks for listening, and do get back to me anytime if you have any particular questions. Okay, so bye bye for now.